Hey.
Hello and welcome everybody to Machine Learning for Games. If you guys could take a minute and silence your phones, shut them off, throw them on the floor, whatever you want to do, just as long as it doesn't make noise, we'd really appreciate it. So we're going to get started. My name is Royal O'Brien. I'm a game developer and a technical evangelist for Amazon, and I love machine learning.
Hey, I'm Darren Briskman. I am also an evangelist and a data scientist at Amazon, and I like to play games.
So today we want to talk to you a little bit about machine learning and how it's become one of the fastest growing and most interesting things in the industry. But before we start doing that, we want to talk to you a little bit about what Amazon is actually doing. And what are we doing in game? And the quick response is we're doing a lot. And we've called it Amazon Game Tech. Now, what it does is it brings a lot of the solutions across the entire life cycle of gaming instead of just focusing on one area. So we're talking about things from global infrastructure and services. These are things like hosting your services, hosting servers, core backends on AWS, as well as some of the Alexa skills, the thing they made for the Destiny 2 Ghost skill. Over to pre-built game services and tools like GameSparks and GameLift. And then over to content creation tools like our AAA engine Lumberyard. And of course, we have distribution and marketing, which is everything from Amazon.com, including Twitch, which really allows you to connect into millions of users all around the world.
Yeah. Can we get back to machine learning now?
So why the slow adoption? Finally. I mean, if machine learning is so important, then why isn't it everywhere already?
Because it's hard. How many people here have actually done machine learning work? Okay, the lights are so bright in my eyes, I have no idea if anybody just raised their hand, but I'm guessing that some of you did. So if you're actually going to do machine learning, you got to do all this stuff. Right? You got to pull the pieces together and pick what framework you're going to use and pull in training data and split it off the confirmation data and figure out what algorithm you're going to apply and do all of that. And it's just way too much work. So we're in the place of machine learning right now, like when programming was that the only language was assembler. Right? So it kind of took, people with PhDs to do it. That doesn't really work because this is not the AI developer conference, right? So how do we make this work?
So the first question is, of course, why machine learning in games, right? So even if they've made this cost-effective and easy to use...
Because we're at the game developer conference, that's why.
Well,
come on.
Going down that road, let's take a look at the journey ahead of what we're going to do today. So today we're going to explore a few use cases. This isn't an academic show, okay? We're actually going to show you where you can use these things. And we're going to talk about pipeline asset management, predicting responses for loot drops and balancing, inappropriate content detection, and abusive content detection and control. And so it's really all about kind of looking at how we can apply machine learning to each one of these different elements to get a value proposition that otherwise makes things easier or more efficient within your games.
Now, back in 2010 at GDC, there was actually some sessions on AI. And it was all, one day we're going to do stuff. Okay, I'm sick of that. Everything you're going to see today, you can do right now. You can go do it today, you can go do it as soon as this is over. If you think we're boring, you can go do it right now when you're sitting there. These are all things that are real and actually exist. It's not future stuff. So we're excited about the future stuff, but here we're going to target in. And I guess, let me throw one thing out. The term used to be AI, so why do we keep saying ML and machine learning? Well, Amazon, we did a little bit of study last year, and we surveyed a lot of customers, and something we discovered is when people hear machine learning, they think of a statistically based analytic tool. And when they hear artificial intelligence, they think of Arnold Schwarzenegger with a shotgun coming to kill them. So we found that for everything except gaming, thinking of a robot coming to kill you is not good for your marketing. Gaming, that sounds like a good game, actually. So, but that's why you're going to hear us using specifically the term ML, because this isn't about that higher level stuff and robots taking away our jobs. This is about actual usable statistical analytics.
And of course, being GDC, instead of us just kind of saying, hey, this is something you might get, you'll actually get to see it in action, live, and then you'll actually be able to go and do it yourself from everything we're doing here. So, and the other thing about it is, while we're talking about some of these implementations, you can write them in many different languages using the Amazon SDK. So whether you're a C++ developer, Node, Android, you want to use server or serverless type technology with Lambda, all these are available to you that you can actually integrate within your titles very quickly and very well documented. So let's get into pipeline asset management. So our first use case is really all about assets and when we're actually working with this. And so let me ask, how many people in here are actually artists or self-proclaimed artists or something of that nature? We've got a few.
You can't see their hands either. Just
No.
don't pretend you can. Too much light.
So, I mean, and how many of you actually spend a decent amount of time in an asset library, kind of flipping through files and links and trying to identify different assets? And yeah, there they go again. And it's one of those things like you have to go and you spend so much time trying to find grass or something like that through this giant library. Or what about if you run into that scenario where you find this texture and it has such an obscure file name that you're just lucky you actually ran into it in the first place? And the problem is that textures and assets, they don't have any kind of like file searching. There's no textual context because it could have grass, it could have rocks, it could be an array of things. So you've got to be able to do that more spatially.
Oh, I know. Let's take all of our artists off of doing artwork and just have them typing in metadata to characterize all the assets. That works well, right? Because artists have plenty of extra time and they don't like have any other work to do.
So this is always the great
that
part
doesn't
for
work.
artists. I get to deal with this as well.
I'm using sarcasm, right? we know that this is not the real problem.
So how many of you actually seen this before? You get that new texture library and they're like, oh yeah, you've got all these new assets. And you go, oh, this is great. I can do so much with it. And oh my God, I got to go through all of these damn things. It's going to take me forever. And that's the problem because you have to get things done. You've got to produce a title. You've got work to do, not play with textures. But at the end of the day, that's the most important part about machine learning. We're going to show you how to actually take a library like this and turn it into metadata so that when you want to find something like grass, it'll actually pull up just the ones you're looking for that either are it or contain it. And the reality is that to build scenes like this one, like out of a lumberyard, you've got to be able to identify what are the best textures that form such a beautiful type environment. I mean, this is the benchmark that you set when we're trying to bring realism to people, or you're spending a lot of time doing it. And so that's part of why we're doing this and the choices that you'll make for how you'll find them. And so if you think about it for a moment, you've got a huge number of textures and backgrounds that you're going to use to build your world. The problem is there's so much information, it just causes a complete overload. And there are just too many choices. I mean, you could be there all day trying to do this stuff. And the metadata is definitely not accurate or even reliable. And the file names can be cryptic or only describe one attribute of it. And it's very problematic. And this is where machine learning comes into play. By actually leveraging the machine learning, you can actually find what the pieces are. So, Darren, let's go ahead and show them.
All right, and we're going to do this with no math. Because in this case, we're using something called Amazon Rekognition. And Amazon Rekognition is one of the tools we have to actually find to look at pictures or videos, but because my bandwidth in here isn't that great, I'll stick with still pictures for now, and be able to say what's happening in that picture. So in this case, I threw up, a grass. Okay, not surprisingly, it found that it's probably flora, probably grass. So one thing here, this is called an inference in machine learning. You never get a yes or no answer, you get a percentage, right? But what's really going on under this, from a programming point of view, is it's giving you back JSON. So what it spits out when you do something like this is it tells you both the orientation as it rotated, and then it gives you JSON and some confidence about what's in that picture. All right, well, this is kind of boring with grass. Let's use a more interesting picture. So let's see. I like let's go for this one. That one's kind of cool. So here's a more interesting picture. And it's going to look at this picture and tell me I got a whole lot of stuff in there. So again, sorry for the bandwidth. There it gets up. It's going to do an analyze. And hey, there's conifers and larches. I have no idea which of these trees is a larch. But I might want to search for what I've got with larch in my stuff. And in this case, further down the list, I find things like rocks and Ericaceae, which is a climbing vine, which I have no idea what that looks like. But the computer does. And by doing this, I can feed in as many pictures as I want and have it spit out that metadata, which I then put into, I don't know, a database, an Excel spreadsheet, I don't care, and go and do that. So this I can do about 100,000 pictures a second through this. So I'll just take my whole library, throw it in, and then spit out the data. It'll take longer to push the words over the line than it'll do to read it. And it is like crazy cheap. That doing that 100,000 pictures, I think, will cost me a little under $1. So this gives me an easy way to use machine learning. And notice I didn't have to go do all the math stuff. This is about using this through APIs. So we'll do the math stuff later, but this is kind of what makes this stuff fun.
And the other thing to note is that if you looked at what he had for what he sent, it was just a base64 encoded request. That's all it was. He encapsulated the image, base64, up it went, response came back. Pretty clean cut. So if you want to go a little deeper into...
Sure. So the service is called Rekognition. Rekognition does a bunch of different things. So when we're running Rekognition, what we were just looking at is what's called object and scene detection. And as I said, that works on pictures. It also works on motion pictures. So I can give it a video clip and it'll say, this is somebody getting out of a car, or this is a combat scene. But it can also do facial analytics. And this works, I guess I could have shown this, but I didn't. I was showing photorealistic stuff. It's also really good at like hand-drawns. So I have like a hand-drawn wood texture or something. It'll tell me that's wood. And that works well with like real faces as well as the big eyes, little mouth of anime faces or all sorts of things that are real or not. And we can do face comparison. Are these the same people in this picture? It's kind of fun for humans because it also look at people at different ages. And then we can also find celebrities. We've got a few million celebrities in there, so we'll find those faces. This is how Royal and I suck up to our boss, by using Jeff Bezos as our celebrity, but it'll find a bunch of other people. And then image moderation, which we'll talk about a little bit later. Now, when we get to the deeper math stuff, we get into a tool called SageMaker. This is about when you have to get into the math, but limit the amount of math that you have to use. So this is our end-to-end machine learning platform where I don't have to set anything up and it will pick the model for you. So when I'm actually doing this stuff, there's big arguments about what are the best models. Should I use MXNet? Should I use TensorFlow? Should I use Gluon? Should I use Caffe? One of these others. If you know what I'm talking about, you know that mostly this is like the modern version of VI versus Emacs. It's something that people love to argue about. By the way, VI. But there we go. But the cool thing about SageMaker is you don't have to pick. You put your data in there and SageMaker will do all that work for you. It will do what's called hyperparameter optimization, which means it'll try your data against different models and see which one's most predictive. And then once this is set up, you now have a model built that you can then submit against. And essentially you pay by the second for how long it takes to crunch your data to come up with your model, and then you throw things back and you'll usually get an answer in about 50 to 100 milliseconds. So this is across all sorts of things I might want to do an inference on. So I'm going to get a little bit deep into the Amazon stuff and then we'll pull back into the fun pieces, because the idea here is at the top level we have these application servers. Application services. And these are services where all you have to be able to deal with is JSON. All you have to do is deal with chunks. So that's things like Rekognition to find pictures, transcribe, which is go ahead and do voice to text, poly, which is the other way around, text to voice. That's tougher than it sounds. So to be honest, it's not yet at a level that it has really good emotion in it, but it is at a level that you can do a chatbot without being deep in the uncanny valley. And we're getting to that emotion stuff pretty quickly as these things evolve. Translate is what it sounds like. How'd you like your game to be in 10 or 20 or 30 different languages without having to do any work? So that's what we get when we combine the translate and the poly. And then Lex is the engine to do chatbots. So come visit the Amazon booth in the expo to be able to see and play with all of these. The next level down is for data people. So that's SageMaker and Deep Lens, which is actually taking data sets and figuring things out of it and doing the math stuff. Deep Lens is a little camera with built-in AI information, which is useful for modeling. And then if you are somebody with a PhD in computer science, all the low-level tools are there. So we have what are called AMIs, which are Amazon Machine Images, that are pre-built, that have R and the latest Python and all of these libraries in it, so you can like dig in there and play with it. So fun stuff for people at every level. All right, so let's actually use this for something. What am I doing here, Royal?
So let's kind of take a little bit of a different path. Now we've looked at this with images and look at how we can say balance the value chain of a game. So when players play a game, they have this hope that they'll be able to get these rare items, and they keep playing, and it's a certain amount of level of play that they keep going, and they hope that they get this special rare thing that becomes their own little personal trophy. But the problem is that it's kind of a balancing act. There's different ways to do it, and there's different models that you can use, but the problem is that if you don't balance these, either it's too hard to get the item, too much grinding, or it drops so many times that it just doesn't have any value to it. And so machine learning can actually come into play by having an impact to this. So in this idea here, we're looking at GameSparks. So they have this really cool system that utilizes loot drops and allows you to set some different models. So there's a couple things you have to think about it when we talk about getting into loot drop cases. So the types of gotcha systems, which ones are going to best suit your game? Box, step, scratch, point, limited number, things of that nature. And then you also have to look at what conditions are you going to reward a drop? How will players react to rare loot drops? And of course, how often should a valuable loot drop actually occur? And so all of these things have a big, big impact on how much they enjoy playing your game and what they're trying to strive for, what brings them back, what's that long tail that you want them to keep playing your game for. And so let's look at one of the cases here. Single spin, equal weight. So the player goes through, he spins, we have a table, they're all balanced with all these different pieces, and it's pretty much even, right? At this point, you're looking at quickly, you can quickly set this loot table up. There's almost no time to manage it. It's really easy to operate. But the problem is that everything has the same weight. There's no special value or chance to receive the reward, so who really cares? It's not really, there's not a lot of game involved. It's just prediction. So let's take a look if we kind of do the regular spin on this where we go, well, let's do a multi-spin with mixed weight. And so the idea, again, the player actually spins. And we have a table, but the table this time has different weights on them. So you have different rare items that have a lower percentage and other items that have a higher percentage so that they kind of get the trash drops here and there, but then the rare stuff goes in. But this is really where the machine learning kind of comes into play, because when you're able to do the adjustments, when you can look at the player data that actually is coming in from the players and how long do they stay in the game and what are they actually doing, and you can get that stuff from GameSparks, and then take that within these fields, feed it into machine language, get it back out with a result, and have it be able to tune those loot drops for you. So they adapt to some of the different gameplay of how do they play during the day, how do they play at night, how do they play in these different countries. So there's a lot of data sets. But again, think of what you'd have to figure out to put that model together. And basically the only person who knows that is this guy.
So and the computer. How do we make the loot drop something that's going to incent the player to do what we want the player to do, right? And you determine, what do I want the player to do? I want to figure out the loot that's going to give this player a likelihood that he's going to play an extra 4 hours this week if I give him this kind of loot. And I want to know that this player will be so annoyed if I give him this loot that he'll play less. So don't give him that. And figure out exactly how I can do that in a way that is meaningful to each person. All right, so how do we do that under the hood? So this is something that's not a simple piece. Instead, we're going to use what's called a convolutional neural network, or a CNN. And when I look at my CNN here, you all have a neural network yourself, right? It's your brain. So the input layer might be your eyes or ears. The hidden layers are the various neurons. So if you know anything about how human vision works, you have different neurons that each are doing a little piece of the visual field, and then they all pull it in. And then it passes to another layer that goes, hey, I could ignore that. Do you remember what the person sitting next to you in the last panel was wearing? It went into your neural network. It just got dropped out because it was, the next hidden layer says, I don't really care about that. It wasn't a threat to me. I can't eat it. It's not going to eat me. I'm good. Move on. And you go through multiple layers until, again, you get an output layer. Now, of course, underneath this is where this gets really cool, because this is when I start putting in the stuff and start looking at the calculations. So like I'll do the inverse of the number of calculations I have here times the sum of squares. And then I have to do that with double the number of variables I have there and then square the variance that comes up. And then when I actually pull this RSS in there.
All right. Way too much math there. Come on, man. This is a show.
Oh, come on. Who likes math? There we go.
You guys are killing me here, man.
All right. But for the other 2/3 of you who like naked people. Okay. So let's talk about how we actually use it. So, joking aside, SageMaker takes all the work out of that. All that math gets hidden. All you need is the data. And it will automatically take care of all of those low-level math things, like figuring out which of those, because everything that we had on this list, this is not made up stuff. Each of these are actually significant machine learning algorithms that you would apply. SageMaker will apply them all and figure out which of these are actually predictive. And we'll do it for you. And again, build the model, confirm the model. How did I do that? I took all the data you gave me about things like players and loot drops. SageMaker automatically holds some back, figure out what's predictive, use the held back stuff to say, did this actually work? Confirm it. So I'll admit, in real life, sometimes you throw this stuff in there, and it says, I can't predict. You didn't give me good enough data. You didn't give me enough data. But usually we can build some sort of predictive model that will let me do a score, or as it's called in the machine learning world, an inference. They'll give me a percentage of something. Such as
Inappropriate content, which we all know and love. So it's another area that you can really make an impact, and that's because there's two areas of inappropriate content. So when you think about it, you have both visual and text, and they really do have different areas, and they can have a big impact on how your players actually enjoy your game, because it's a quick way. If things become toxic, they leave, and you may not get them back. There's always another game out there ready to pick up your customers, period.
Yeah.
So I know we've all read about those events where somebody has an avatar system and it's gone completely awry, and where people have posted everything inappropriate as an avatar, or they have user-generated content, and God knows what they pull from where.
Because that's just hilarious to put a naked picture in your avatar.
But instead of following the general premise, of your game, they just go crazy. They start putting all kinds of adult things, and they just go off to left field. And when I mean left field, I mean really, really left field, like way left field, like red light district, and just off to the.
That's enough detail here. Just stop. Yeah. So so I want to find a naughty picture without having to pay a team of humans to look at it, right? These pictures are not very naughty, but they're as naughty as I can put up on a screen at a conference like this. So here we're using that recognition service again, but this time we're going to use it to actually look for, is there content in a picture? And then what do I do if the content is inappropriate? Then that's up to you. But this will tell me, is this inappropriate? So as we flip back, one of the things I love about this is, of course, we blur it when we show the picture. So here's the girl there, but notice what it came back. It came back, okay, there's a 62% chance this is suggestive, and a 57% chance that this is nudity. Now, in this case, it's not really nudity. She's dressed appropriately for a beach. But is this an appropriate picture for your game or your world? Depends. If I have a game that I'm aiming at like 10-year-olds, this is probably not a picture that I want to have in there. If it's dead or alive, then this picture is perfect. And it's exactly what I want. And some of our customers use image moderation to put in images that they're looking for. But this would also give me some other pictures. So let's look at the guy and see what that tells us. So we have this lovely open source picture of a guy in a Speedo. And we'll give it a moment to analyze that and see what it says about him. And again, this one's 98% certain it's suggestive. And figures there's an 80% chance that there's nudity. And indeed, if I go back and look at that, let's just say there's a package there that implies things that one might not want to have in the gaming world. But can you see how you would use this? And again, what I send in is just an image. And what I get back, which is easy to use as a programmer, is what the problem is, which in this case is almost always going to be some variant of suggestive and nudity, and the percentage that is something that's there, and very specific. So notice this doesn't say it's a man, it says it's a male with swimwear or underwear that we have. So then we can then decide, is this something I want to rule in or out? Because even if you have a game like Dead or Alive and people are putting in, avatars or other stuff, I don't want fully explicit nudity. There's a line at which I want to cut it off. That was a bad choice of words. But under all this makes it easy to do this. And can you see how this one, I don't need to know any of the math, right? This is, again, just dealing with JSON. But also, this frees up huge amounts of humans. Because now you only send it to humans for those corner cases. And you can use this to eliminate this out. So we use this in gaming. A lot of our customers who do dating sites will do this. The customer who we actually originally did this for is eBay, because they had the problem that people would take pictures. I'm selling a mirror, and they'll take a picture of themselves naked in the mirror, and it's never the kind of people you want to see naked who do this. So this really became a serious issue for these companies. But this is the kind of thing that we can do with machine learning today. It's giving you a taste of what I think we're going to see in the future.
And the other thing to remember is to use all of these, all you need is an AWS account. And you can do this serverless. So that means that you can have it do this in automation, where you're basically firing these out as you see needed and get the responses back without having to just stand up entire instances. And it's all readily available.
And when I said you could do this right now for free, when you do it one picture at a time, it's free. Right? When I upload a few thousand pictures, then it's like some micro pennies per picture.
So let's go into another area here. Well, I should switch this back.
Yeah, you should stop looking at the guy.
I know. So the next area we want to talk about is basically, it's kind of a different area of inappropriate. And in many cases, it's actually abusive. It's really normal for people to kind of express their views when they're playing a game. They're fueled by adrenaline, they're playing, they're into it, it's great, but the problem is there's a fine line to actually tip it from exciting adrenaline rush to toxic abusive behavior where they're actually just attacking other players. And it's just this quick derailing that happens that you just see your community just starts to kind of suffer as a result. And then you have some kind of an event that everybody's writing about that you really don't want to happen. It's really problematic, and this is another area that you can actually apply machine learning.
Sure. So this application we call Comprehend. So Comprehend does a whole bunch of things. So one, it can take in text or speech. So if you give Comprehend speech, it will turn the speech into text for you, and that's part of what, say, Alexa uses. When you ask Alexa a question, she's actually using this service to turn that into text. But more interestingly is the entity analytics. So in Alexa's case, it'll figure out, am I talking about weather, am I asking about sports, or am I asking to play a song? When we do things with text, it will pull entities out and say, this is medical text, or this is text about, this is a manual for a game. But here, the other thing that we really have that's interesting is sentiment analysis. Is somebody being abusive or negative? So what's that like?
So really, how does it relate, to a gaming perspective? There's a lot of different players and personalities. The problem is that, when they're focused more on the other players than playing your game, that's part of the problem. And at the end of the day, we know them. They're always in every game, and otherwise known as the Troll Kings. You know you love me. And this is the kind of individual that goes in and they have the chat system and they find somebody to start picking on, and they go at it and at it and at it, and then your users start reporting this kind of abusive behavior, which means now you have a cost in support that you're going to have to deal with in your community, no matter what. And you've got to find a way to kind of curb some of this. And the nice part is by using Comprehend, you're actually able to gain understanding with the sentiment of what's going on. And that's really a big thing because it helps kind of get rid of some of the false detects and things of that nature. So think of it this way. I'm in the auction house, and I'm playing it. I'm buying and selling stacks of a rare aeroponic processing unit, bidding it up and down to kind of make money. And another guy who's basically bidding against it just gets bent out of shape. And he sends me this in-game message. Now think about the context of this for a second. You know what you did, you stupid freak. You haven't learned anything. You will. Payback is coming. You don't deserve to know how. As far as you know, it's just the start of the payback. You know how to make all of this stop. Even someone as stupid as you can figure it out. Now imagine that kind. Now, did anybody see a single...
Hold on. You did that a little too well, Royal. Is this like an actual text exchange from you gaming in this? Because this advantage is hitting like close to the heart for you.
Oh, it's the love of games. But something to notice. Did anybody here see a single foul word in that whole entire set?
Right.
Anything with profanity?
But this is toxic, right? This is the kind of stuff that's going to drive people out of your game when they see it.
And so that's really about the inappropriate... Yeah, let's switch it back over.
So this is the Comprehend console. You want a moment to come up. So as you'd expect from Amazon Web Service, it's really boring. And we're going to throw in this chunk of text. Whoops. I'm going to hit the wrong key. There we go. We're going to throw in this chunk of text. And I don't have it copied. We're going to throw in this chunk of text. And then tell it to analyze. And again, everything comes up in JSON. So here it didn't find an entity. It didn't find persons or organizations. It did find some phrases like freak and payback and what it considers are key phrases that tell you what is going on in there. Figured out the language was English. That's useful. But the thing I care about for this is that it said, there's an 84% chance that this is negative sentiment. So it doesn't mean I want to throw them off, but it does mean I want to prevent people from having too much negativity. And again, just like before, underneath, there's my text block in JSON, there's my response block in JSON. So the sentiment is mostly negative, and then here's the other pieces here. Now, what I find amusing about this is usually we can get a pretty good percentage. Sometimes we have challenge. I was doing this with one of our retailing customers, and they were looking at tweets. And somebody said, my mother bought a dress, and it's really sick. And we're all going, is that good? So it's not a perfect system, but it helps us figure out, I've got some negativity there without obscenity. but something that I want to avoid. So what do I do with this, Royal?
Well, one of the things also to take note is that there are things like semantic variations, incorrect spelling, acronyms, memes, slang. These are common things that they'll use to kind of defeat many of those types of systems. But it's not about the words, but it's about the intent of the words. And that is kind of the fundamental basis. If any of you have listened to the things going with like Alexa and the machine learning behind it, it's all about the intent of what is actually being conveyed. And that's why it's able to actually see things or understand things with a different type of context than traditional systems would.
So let's throw that in. This is the key difference between machine learning and other sort of analytics. Right? Because machine learning is just another analytics tool. But traditional analytics, which is going to be around forever because it has its place, is all rules-based. If X, then Y. If not Y, then Z. And you end up creating all these rules. Machine learning is purely statistical. Machine learning is, I don't know why that's negative. I don't know what word is negative. What I know is somebody gave me 100,000 examples of text, and of which 5,000 were negative. And these are the things that I found in text that is negative. And this one looked more like the negative text than it looked like the mixed test, positive test. It doesn't know why. It doesn't care why. It just created an inference. And this is how you can, therefore, machine learning can work its way around all the tricks about misspellings and word things and whatever, because I'm not looking for particular words. I'm looking for things that statistically look like negative text.
So let's think about this for a second.
Can I get back to the math now?
No.
Damn it.
So let's take a look at, kind of an implementation. What's an example of something you can use this with? In an abuse ticket, you have, your troll abuser and your game player. And so what's going on is, each one of them are chatting and it's going into their own game logs. So you've got recorded text on both sides that are happening. And then they start exchanging with each other. The troll's starting to hit the game player. They're going back and forth. Well, at this point, the game player is probably going to create an abuse ticket of something that's happening that you're going to need to address. And so from that point there, you're going to take logs and pretty much with the ticket and determine, some human's going to have to look at it and make an interpretation. What is this? And that's head count. Well, by using comprehend, you can actually take that data and actually put it in a REST API call with the text, have comprehend actually evaluate what it was with the keywords and the sentiment, and then return back the results and actually file that into the ticket. So now you have a general understanding of what an opinion is on that piece in your implementation. Now this is a starting block, because now you have all the information that arms you to be able to do something with it. So let's do something with it. So now we can talk about automatic filtering and prioritization. How do you actually figure out which ones need to be addressed now versus the ones that could be left off a little bit later? Well, let's take a look. Is it the sentiment more than 50% positive? It's probably a false one. You may filter that out. These are things you can adjust that are pretty easy. But if it's negative and it's greater than 50% negative, well, how negative is it? Is it more than 75%? That's probably a priority one abuse that you know that you're going to need to address right away, because it's a really big problem. Somebody is getting nasty in your game and somebody's going to walk. So let's just go back a moment and say, well, it was negative, but it was kind of mixed in there. So perhaps that's a priority 2 abuse, or maybe it was kind of borderline on 75. And again, if it was neutral, maybe a priority 3 abuse. Less than 50% positive, but none of the others, it would be a low priority abuse. But now you have a model in which you can accelerate things. Because at the end of the day, the value proposition is you can reduce the headcount for support, increase response, and be able to address escalated issues. At the end of the day, everybody loves a meme, but nobody wants their game to become one. And this happens all the time. You'll see something on a feed where somebody just started going haywire on someone else, and your game's entangled in the middle of it. And some people are going, I don't want any part of that.
Yeah, but Ryle, I mean, this still requires a human, right? This is ticket management.
Well, that's...
I want this to all work on its own.
Well, going through a lot of that stuff, you can. Actually, you can do quite a bit of the automation outside of that. And that's where you can do some of the live chat feed moderation. And so let's just say we take that abuse as it's actually happening. And we take a look at what's been posted in the channels as well, because you need a reference point. If the whole channel is being toxic at one time, how do you single someone out? But you have a reference to work with now. And so you take the REST API with the logs, you send it up to comprehend, get your sentiment results out, and then you calculate the average channel sentiment and the user sentiment. Let's find a baseline. Where did this thing start going downhill? Who were the people that started it? How can we track this? Because if you were to put it all on a graph, you could see the negative sentiment of the different people as it changes. So once it passes a certain threshold of negative sentiment, then you can actually take that user who's chatting in-game and just delay their response. You don't have to necessarily attack them, just don't let their next message come through right away. Maybe delay it 5 seconds. Because everybody knows that if you try to squelch a troll by attacking him direct, he's going to just change accounts. And he's going to get back in the game and just keep on attacking. But if you start to time someone out into oblivion at a slow, steady rate, you're most likely going to be able to get them to either go back to focusing on the game, because they're not a real troll, they're just kind of whatever, they got angry at work, or their dog peed somewhere on the floor, who knows. But it at least gets them to go back to what you want them to do, is to become a productive game player in your ecosystem, in your community. And that's what's really important. So,
and hey, maybe they weren't a troll. Maybe there's somebody who just issued one negative comment. So we just slow them down for a minute. Now, I have easy services like Comprehend to do this with text. By using a little bit of SageMaker, you can do exactly the same thing with aimbots and killbots, right? You can watch and say, is there a player playing my game inhumanly well? If so, slow them down. Don't kick them off, because maybe it's fatality, maybe it's a really, really amazing esports champion who happens to be playing your game. But slow them down to a human level, which it's because it's unfair to the other players if somebody like that is playing your game. Anyway.
Well, you don't want to take all the color out of the game. Just because somebody gets upset doesn't mean that it's all of a sudden the squeaky clean game. You just want to slow the abuse down, because a certain level of aggression is common in the games, and without it, you're really taking a lot of colors out. So if they continue being excessive, at that point you can suspend their chat and just take their voice away entirely. Or if they're doing fine after the response has been delayed, or they haven't really passed that threshold, you can go ahead and release the messages to the server, allow them to keep communicating, and then show it within the game stream. And you can really do this almost anywhere, whether it's like in an MMO or other kind of chat systems where you're actually doing a lot of these pieces. And that's the point of it, is you want to make sure that you're servicing your community, giving them the best experience without actually just killing people on the spot. And so there are definitely ways to do that. And you can also incorporate other things like AI NPCs that can also appear or come in and notify a GM to say, there's a lot of negative sentiment going here. I want a GM to come here now because I can see statistically this is a problem. Which means that you don't have to worry about this thing becoming a really big problem on a ticket. It happens while it's escalating, which means you can address it on the spot. So again, why should you care about machine learning at the end of the day? For one, we look at it. You're able to reduce a considerable amount of time for artists and content creators so they can build beautiful games with Rekognize. You're talking about feeding in a whole pipeline of assets, being able to do a search straight down and go for it. And the best part is, it doesn't have to be perfect real life. It can be hand-drawn, it can be artist-drawn. Any of those things. When you have an artist who starts building textures, they're not going to meta tag them. And if they do, you're lucky. But, the bottom line is that they make a hand-painted door. You want it to understand that it's a door made of wood, not just because it looked like a photograph. The other thing is that you want to help grow your long tail, and you want to add value to your in-game loot drops. The more balance you give this, the more people who are going to play your games longer, the more people that you can actually keep in there, your long tail goes, your content continues to grow, your community grows, and that's just a win all the way across the board. And the best part is you don't have to have a body actually looking at these numbers, trying to make these little tweaks. You can set values and parameters and do this in automation, and you can do it now. And then, of course, you can automate and address any of the inappropriate content before it becomes a problem. So when somebody starts uploading these naughty pictures or things like that shouldn't be in your game, you can pretty much nix it out immediately. As soon as it gets posted, it goes up, it gets a rating, it's got to go to review. But at least you know that it's at least what you believe it to be, that you can handle it, so you don't have things just entering into your game, causing these avatars that are disrupting people, especially if you have a younger crowd. If your game's not focused purely on adult, then this is actually a pretty good way to get that done without having to increase your head count to do it.
Or if you have an older crowd, I don't really want the people in Scrabble trash-talking me. So what does everything we just showed you have in common? Two things. One, it's all real. It's all now. Stuff you can do today. Two, it's a little bit boring. right? This is not like the future of complete, AI content creation that creates the game for you and creates millions of NPCs that each have their own personalities and automatically react to people. Will we get there? Yeah. But we wanted to show you something of real machine learning that works in March 2018, not stuff that people think will show up one day.
And that's the idea behind this. So, again, we want to thank everybody for coming out. If you'd like to learn more, please go down to where the kiosk is. We have number 29. You can answer a lot more questions. Darren and myself and many others will be there. If you want to learn more about GameSparks and some of those pieces with that, they're over at kiosk 14. And if you're interested in the Lex Poly, the voice and how that works, they're kiosk 32, where it's the characters that actually listen, learn, and adapt to your voice.
And these are all kiosks within the Amazon section of the expo, and if you can't find it, it's the tacky bright orange stuff. So
Thank you very much.
All right.